Now let's do question number 7. In this section we will learn some important properties of definite integrals. So these properties will be very helpful in solving the definite integral questions. The first property, integral a to b f of x dx is equal to integral f of t dt. This can be proved very easily by substituting x as t. Let us take x as t, so dx will be dt. The limits will be the same because x and t are equal. Therefore, the left hand side becomes integral a to b f of t dt. So in case of definite integral questions, the variable is a dummy variable. Because the answer is not going to be in terms of x or in terms of t. The answer is going to be in terms of a and b after substituting the limits. Integral a to b f of x dx is equal to minus integral b to a f of x dx. If you interchange the limits, you have to write a minus sign. This property can be proved easily using second fundamental theorem of integral calculus. Let us take the left hand side, integral a to b f of x dx. Let the integral answer be capital F of x and the limits are a to b. Apply the limits. We get f of b minus f of a. Let us take the minus sign out. We get minus of f of a minus f of b. And this can be written as minus integral b to a f of x dx. And this is the right hand side. And in particular, if the limits are a to a f of x dx, say, let the answer be capital F of x and the limits are a to a, upper limit minus lower limit. Therefore, the answer becomes 0. Third property, integral a to b f of x dx is equal to integral a to c f of x dx plus integral c to b f of x dx. This also can be proved using second fundamental theorem of calculus. Let us take the right hand side. Let the integral of f of x be capital F of x and the limits are a to c, and for the second integral the limits are c to b, where c lies between a and b. Now this is f of c minus f of a plus the second answer will be f of b minus f of c. F of c is getting cancelled and we get f of b minus f of a, which is integral a to b f of x dx, and this is the left hand side. And this property especially we use for questions which has absolute value function, or when the definition of f of x is two different definitions we have. For example, for x greater than or equal to c1 definition, x less than c1 definition, say. So we split and do the integration. So for these two types of questions we use this property. A to b f of x dx is equal to integral a to b f of a plus b minus x dx. Let us take the right hand side. Integral a to b f of a plus b minus x dx. This can be easily proved by substitution. by substituting a plus b minus x as t. Let us differentiate. A and b are constants. So differential of minus x is dx minus dx equal to dt. Let us change the limits. When x is a, substitute here. A plus b minus a and a are getting cancelled, t becomes b. And when x is b, a plus b minus b and b will get cancelled, t becomes a. Let us substitute the corresponding limits for t. The lower limit becomes b, the upper limit becomes a. F of a plus b minus x is t and dx is minus dt. Let us write the minus sign outside the integral and dt. If I interchange the upper and the lower limits, let us flip the limits, it will become minus of minus plus. And in case of definite integrals, we know that the variable doesn't matter, it is a dummy variable. In definite integrals, whether you write the function in terms of t or in terms of x does not matter. And this is the left hand side. Next, P4 property. Integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. This property is one particular case of the previous one. So same method we are going to use to prove this, and the proofs of these two properties are important. They have been asked in the board exam. Integral 0 to a f of a minus x dx. Let us substitute a minus x as t. Differentiate both sides. Minus dx is dt. Let us calculate the corresponding limit values for t. When x is 0, substitute x as 0 here, t becomes a. And when x is a minus a, t becomes 0. Therefore, the corresponding limit values for t are a and 0. F of this is t and dx is minus dt. Let us write the minus sign outside the integral. Let us interchange the limits. We will get a minus sign. So minus of minus will become plus. Integral 0 to a. I am changing the variable f of x dx, because in definite integrals the variable is a dummy variable. We can write it in terms of any variable. And this is the left hand side. Property P5. Integral 0 to 2a f of x dx is equal to integral 0 to a f of x dx plus integral 0 to a f of 2a minus x dx. By the P2 property, we can write integral 0 to 2a f of x dx as 0 to a and a to 2a. That is splitting the interval 0 to 2a at a. So it becomes integral 0 to a f of x dx plus integral a to 2a f of x dx. Now the first integral is this. We have to prove that the second integral is this. Let us take this integral as I, a to 2a f of x dx, and substitute 2a minus x as t. Differentiate both sides. Minus dx is dt. Let us calculate the limits for t. When x is a, the lower limit is a, t will be, substitute here, 2a minus a, t becomes a, and upper limit. When x is 2a, 2a minus 2a, the upper limit becomes 0. Therefore, it becomes integral. The lower limit is a, the upper limit is 0. And x will be from this, x is equal to 2a minus t. It becomes 2a minus t, and dx is minus dt. I'll write the minus sign outside, dt. I'm changing the limits. I have to put a negative sign. Minus of minus will become plus. If I interchange the limits, minus sign comes out. So it makes the negative sign positive. And we have f of 2a minus t times dt. Now in case of definite integrals, the variable does not matter. I can write this function in terms of x. So f of 2a minus x times dx. Therefore, step 1 becomes integral 0 to 2a f of x dx is equal to, the first integral is the same, integral 0 to a f of x dx. I am writing equation 1. And for this second term, I am substituting the answer which I got now, which is integral 0 to a f of 2a minus x dx. Next property, P6, integral 0 to 2a f of x dx is 2 times integral 0 to a f of x dx if f of 2a minus x is equal to f of x, or it becomes 0 if f of 2a minus x is equal to minus f of x. Let us prove this property. By using P5 property, we can write integral 0 to 2a f of x dx as, I am using the previous property, it becomes integral 0 to a f of x dx plus integral 0 to a f of 2a minus x dx. Integral 0 to a f of x dx. Now see the second integral. If this condition is satisfied, I can replace f of 2a minus x by f of x. Now these two integrals are same. Therefore, the answer becomes 2 times integral 0 to a f of x dx. This is the first case. Now again in equation 1, integral 0 to 2a f of x dx is equal to integral 0 to a f of x dx. Now let us consider the second condition. If this condition is satisfied, then the second integral becomes integral 0 to a minus f of x dx. So both are same integrals with positive and negative signs. Therefore, the answer becomes 0 for the second case. Now next property, integral minus a to a f of x dx. This becomes 2 times integral 0 to a f of x dx if f of minus x is equal to f of x. That is, f is an even function. Or it becomes 0 if f of minus x is equal to minus f of x. That is, f is an odd function. So these are the definitions of even function and odd function. If f of minus x is plus f of x, then it is an even function. For example, y is equal to x square. X square is an even function. And if f of minus x is minus f of x, then it is an odd function. Example is x cube is an odd function. Let us prove this property. Now I will use P2 property, that is splitting the interval. The given interval is minus a to a. I will split this interval at 0, the mid value, minus a to 0 f of x dx and plus 0 to a f of x dx. Let us substitute x as minus t for the first integral. Dx is minus dt. Therefore, the first integral becomes, we have to change the limits. When x is minus a, t becomes a. And if x is 0, t is also 0. And here it becomes f of minus t and minus dt. I'll write the minus sign outside. The second integral, I'll keep it as integral 0 to a f of x dx. Now let us flip the limits. I will get a negative sign. So minus and minus will become plus. I get f of minus x dx. The variable can be changed. The second integral is the same. If f of x is an even function, say, that is f of minus x becomes f of x. It becomes f of x because it is an even function. Therefore, the answer becomes 2 times integral 0 to a f of x dx. Then it is an even function, if f is even. Whereas, if f is an odd function, in that case, f of minus x is minus f of x. So in case of odd function, the integral becomes minus integral 0 to a f of x dx. And the second integral is 0 to a f of x dx. They get cancelled. The answer becomes 0. Therefore, if f is an even function, integral minus a to a f of x dx becomes 2 times integral 0 to a f of x dx. And if f of x is an odd function, then that integral becomes 0. Now, using these properties, we will do the questions of exercise 7.11. First question, integral 0 to pi by 2 cos square x dx. We can do this question using the identity cos square x is equal to 1 plus cos 2x by 2. But in this exercise, we have to evaluate the integrals using the properties. Let us use integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx property. I will take the given integral as I and use this property, integral 0 to pi by 2 cos of pi by 2 minus x square dx. A here is pi by 2. So I have to replace x by pi by 2 minus x. And we know the formula, cos pi by 2 minus x becomes sin x. So we get sin square x dx. Now let us take this as first equation, this as second. We will add them. This is also I. So the left hand side becomes 2I. Integral 0 to pi by 2 sine square x plus cos square x. I can add the integrands because the limits are same for both, and use the identity. I is equal to half into integral 0 to pi by 2 sine square x plus cos square x is 1. See how easy the integration has become. Integral of 1 is x and the limits are 0 to pi by 2. So half into upper limit is pi by 2, lower limit is 0. Therefore the answer is pi by 4. Question 2. Integral 0 to pi by 2 root of sin x divided by root of sin x plus root of cos x dx. Let us use the same property. Integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Let us take the given integral as I. Integral 0 to pi by 2. A here is pi by 2. So the function becomes root of sine of pi by 2 minus x divided by root of sine of pi by 2 minus x plus root of cos of pi by 2 minus x times dx. Integral 0 to pi by 2. Sine 90 minus theta is cos theta, we know. So it becomes cos x divided by, similarly, in the denominator we get root cos x plus root sin x and dx. This is equation number 1. This is equation number 2. Let us add them. This is also I. So the left hand side becomes 2 times I. Integral 0 to pi by 2. They have the same limits. And these two integrands, they have the same denominator, which becomes the LCM. Now add the numerators. So we get root of sin x from the first equation and root of cos x from the second equation. Therefore, I is equal to half into integral 0 to pi by 2. This function becomes 1. And the integral is x. The limits are 0 to pi by 2. Half into upper limit minus lower limit. Therefore, the answer is pi divided by 4. Third question, exactly the same type. Integral 0 to pi by 2 sine power 3 by 2x divided by sine power 3 by 2x plus cos power 3 by 2x dx. Let us use integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx property. Therefore, the given integral becomes integral 0 to pi by 2 sine raised to 3 by 2 pi by 2 minus x divided by sine raised to 3 by 2 pi by 2 minus x and plus cos raised to 3 by 2 pi by 2 minus x dx. Integral 0 to pi by 2 sine 90 minus theta is cos theta. So it becomes cos raised to 3 by 2x divided by cos raised to 3 by 2x plus sine raised to 3 by 2x dx. First equation, this is the second after using the property. Let us add them. The left hand side will become 2 times I, and the right hand side, the integral is common. Denominator is also common, which becomes the LCM. Let us add the numerators. Therefore, it becomes 1. So, I is half into integral 0 to pi by 2 1 dx. Half into x between the limits 0 to pi by 2, which is half into pi by 2 minus 0. Therefore, I is pi by 4. Question 4. Same type. Let us take the given integral as I, which is integral 0 to pi by 2 cos raised to 5x divided by sine raised to 5x plus cos raised to 5x dx. We will use integral 0 to a f of x dx property, which is integral 0 to a f of a minus x dx. A is pi by 2 here. We know that sine 90 minus theta is cos theta and cos 90 minus theta is sine theta. So it becomes sine raised to 5x divided by cos raised to 5x plus sine raised to 5x dx. First equation. Second, let us add them. The left hand side is 2i. The right hand side, the LCM is sine power 5x plus cos power 5x. Add the numerators. Here also the integrand becomes 1. Therefore, I is half into integral 0 to pi by 2 1 dx. Half into integration is x. The limits are 0 to pi by 2. Substitute the limits. Half into pi by 2 minus 0. The answer is pi by 4. Now let's do question number 7. We'll do all questions where we use that a minus x property. And then we will do the other questions. Integral 0 to 1 x into 1 minus x raised to n dx. We are not able to open the brackets and distribute this x because of this power n. We can do this question by substitution. By substituting 1 minus x as t, we can solve this question. But here we have to use properties. So let us use a minus x property. Integral 0 to a f of x dx is integral 0 to a f of a minus x dx. I will take this as I. Therefore, we get integral 0 to 1. In this question, a is 1. So, wherever we have x, replace it by 1 minus x. 1 minus of 1 minus x raised to n dx. Let us simplify the function and write integral 0 to 1 minus x times x power n dx. Now we can distribute and write. integral 0 to 1 x raised to n minus x raised to n plus 1 dx. Now we can easily integrate each term. Integral of x power n is x power n plus 1 divided by n plus 1, and the limits are 0 to 1. Integral of the second term, x raised to n plus 2 divided by n plus 2, and the limits are 0 to 1. 1 divided by n plus 1, upper limit is 1 raised to n plus 1. 1 power any number is 1, and 0 power any number is 0. Similarly, here also we get 1 minus 0. Therefore, we get 1 divided by n plus 1 minus 1 divided by n plus 2. Let us take LCM. N plus 1 times n plus 2 is the LCM. We get n plus 2 minus of n plus 1. The answer is 1 divided by n plus 1 times n plus 2. Question number 8. The given integral is 0 to pi by 4 log of 1 plus tan x dx. We'll use a minus x property, that is integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Therefore, the integral becomes integral 0 to pi by 4 log of 1 plus tan of a, here is pi by 4. So, it becomes pi by 4 minus x dx. Tan of a minus b is tan a minus tan b divided by 1 plus tan a times tan b. Therefore, the given integral becomes integral 0 to pi by 4 log of 1 plus tan a here is pi by 4, tan 45 is 1, minus tan b, which is tan x, divided by 1 plus tan 45 is 1 into tan x dx. Let us simplify this. Log of, take LCM, we get 1 plus tan x plus 1 minus tan x dx. Integral 0 to pi by 4, it becomes log of 2 divided by 1 plus tan x dx. We will take the given integral as 1, this as 2. We will add them. The left hand side becomes I plus I, 2I is equal to integral 0 to pi by 4 log of 1 plus tan x plus log of 2 divided by 1 plus tan x and dx. And log a plus log b can be written as log of a into b. Let us use the logarithmic rule. I becomes half into, it is better to take 2 to the other side in the next step itself, otherwise we may forget to take 2 to the other side at the end. So half into integral 0 to pi by 4, it becomes log of a into b. into dx. Log 2 is a constant. Take it outside the integral. So we'll be having integral 0 to pi by 4 1 dx, and the integral is x between the limit 0 to pi by 4. Upper limit is pi by 4, lower limit is 0. Pi by 4 minus 0 is pi by 4. Therefore, the answer is pi divided by 8 times log 2. Question number 9. Let it be I, which is integral 0 to 2 x times root of 2 minus x dx. We will use 0 to a f of x dx is equal to integral 0 to a f of a minus x dx property. Integral 0 to 2, a here is 2. So replace x by a minus x, which is 2 minus x. 2 minus of 2 minus x dx. Integral 0 to 2, 2 minus x and root x dx. Now we can distribute. This question can be done by substitution method also. By substituting root of 2 minus x as t or only 2 minus x as t also we can do. But in this exercise we have to use properties. That's why we are using properties. Integral 0 to 2, 2 times x power half minus x into root x becomes x power 1 plus half is 3 by 2 times dx. Let's integrate and write. 2 times integral of x raised to half is half plus 1, which is 3 by 2 divided by 3 by 2 will become 2 by 3, and the limits are 0 to 2, and x raised to 3 by 2 plus 1 gives you 5 by 2 divided by 5 by 2 will become into 2 by 5, and the limits are 0 to 2. 4 by 3 times 2 power half is root 2, and we have cube, lower limit is 0. 2 by 5 times 2 power 5 by 2. 2 power half is root 2, we have root 2 power 5, and the lower limit is 0. Let's simplify further. 4 by 3 times root 2 into root 2 into root 2, which is 2 root 2. And this is 2 by 5 times 2 2s are 4, 4 root 2. Let's take LCM. LCM is 15. So 5 4s are 20, 20 times 2, 40 root 2 minus 8 3s are 24 root 2. Therefore, the answer is 16 root 2 divided by 15. Question number 10. I is equal to integral 0 to pi by 2, 2 times log of sin x minus log of sin 2x dx. Let us simplify this. We will take this 2 as the power so that we can combine the log terms. Integral 0 to pi by 2 log of sin square minus log of sin 2x dx. Log a minus log b is log of a by b. So the function becomes log of sin square x divided by, write sin 2x as 2 sin x cos x, so that we can simplify further. Therefore, the function becomes log of tan x divided by 2 dx. So far we have simplified the integrand, the given function. Now we are going to use the property. Integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Therefore, the integral becomes integral 0 to pi by 2 log of tan pi by 2 minus x divided by 2 dx, which is integral 0 to pi by 2 log of tan 90 minus theta is cot theta dx. Now we will take this as first equation and this as second. Both are same integrals. We will denote them as I. We will add 1 and 2. The left hand side becomes 2i and the right hand side is integral 0 to pi by 2 log of tan x by 2 plus log of cot x divided by 2 into dx. Now log a plus log b can be written as log of a into b. Take this 2 to the other side. Integral 0 to pi by 2 log of tan x divided by 2 into cot x divided by 2 using the logarithmic rule. Tan and cot will get cancelled because cot x is 1 by tan x. And we have log of 1 by 4, which is a constant, and it can be taken outside the integral. Half into log of 1 by 4 integral 0 to pi by 2 1 dx, half log of 1 by 4 x, and the limits are 0 to pi by 2. Let us substitute the limits. Half log 1 by 4 times pi by 2 minus 0. Therefore, the answer becomes pi by 4 log of 1 by 4. Or we may simplify this answer further. Let us write that 1 by 4 as half square. Therefore, it becomes 2 times pi by 4 log of 1 by 2, which is pi by 2 into log of half.